Okay, welcome everyone to this week's Compiler Architecture meeting. So we have one topic today. Nazim will be giving an update on some of the work that he's been doing to prototype a new scheme for processing compiler options. If you recall, we've discussed this topic a few months back, and really just to sort of introduce and frame why we want to do this and the problems that we were facing and what a new architecture might look like. Over the, on and off for the last few months, Nazim has been able to spend some time working on studying the problem a little bit more and coming up with some different solutions. So what he'll be talking about today is sort of the progress of that, and one of the solutions that that looks fairly promising that I think we might consider adopting in OMR and other downstream projects. So I'll turn it over to Nazim to take us through it.
Thanks, Cheryl. Thank you for making it here, and I just wanted to use the time in this meeting to go over what I've been able to come up with so far regarding reworking the problems we have been having with options class. And okay, so just to recap, the main motivations behind wanting to rework OMR options is because of the fact that it's not very beginner friendly. It currently, as in its state, it's just a giant confusing mess that someone will take a long time to figure it out. Based on my experience, yeah, it hasn't been pleasant. And another thing is that using the class is a little bit more complicated than it could be. And now that OMR is an open source project, someone who's a new developer to OMR, and if they want to add any of their own options, that's not very straightforward. For example, adding a boolean option right now would mean requiring a change in OMROptions.json, as well as a table entry that is in an array that is alphabetically sorted by the option name in OMROptions.cpp. And then, that's not a very neat way to add one. And another issue we have is that the current implementation limits us in the sense that a lot of the downstream project options cannot exist in the projects themselves, and they have to exist within OMR. And there are many other issues, but these are just some of the significant ones. So I have recently opened a PR, and it outlines some of the main components of a new solution that I've been working on a couple of months in the past. And what it does is it implements just the processing of Boolean options. And previously, like in the current implementation, it's using option flags and using bitwise operations to store and read options as well. And it's just the first of a number of PRs that will be needed to get this fully integrated and working in a way that it can totally replace the existing options class. And along the way, there were a number of design decisions we had to make. And some of the significant differences are that Boolean options, which is the only thing that I'm handling right now, they are not stored in a single array using option flags anymore. So in the options class, the class that stores the options themselves, each of the options get their own field. And then there are So basically, these members, they're not hard-coded. They are actually generated at build time, and those generated files are included within places where we need those data. And we'll get into the details about that in upcoming slides. So we have one input JSON file for OMR, and downstream projects can have their own JSON files containing their own options. And then another design change that has happened was that we no longer use an ordered array anymore for matching option strings. What we instead use is a hash table that is laid out during build time. And yeah, we'll talk more in details about that later. But first, let's look at some of the justifications behind using boolean options members instead of continuing to use the options array field. So OMR options uses some like option flags defined in an enum called the compilation options, and that enum is used to read the value in underscore options array. So every Boolean option that we wanted to have in OMR, they needed a spot in that enum, and adding a Boolean option, yeah, so what happens with this implementation is that we cannot separate OMR options from downstream options. So downstream projects will have to have their options here as well. And this is a big problem because of the fact that there is a limit to the number of options that we have, because these enums are these enum members are defined to fixed values. So there is a range, and the maximum number we can have it is about 830 members. So, and another disadvantage of using that is that looking up of these options, which happen quite often at runtime, is more expensive than just looking up Boolean fields. So, which is why I've looked into using Boolean fields instead. And there are a number of benefits that this brings. And one is there is no limit to the number of options that we can have. And it also opens a path for us to use, to separate out the downstream options from OMR. And so the project specific options can stay there. And so the OMR options and the project specific options do not have to worry about each other. And then another advantage is that querying of these options, which I mentioned is something that happens quite often, is actually 2 to 3 times faster than using bitwise operations to extract the Boolean information. And I've done that by writing a small test, making 1 billion queries of different options in the 2 different implementations. And the fact is that using Boolean fields does increase the size of our class, the options object. But the thing is, given the number of querying we do reduce the number of instructions needed to extract the information quite a bit. So I think this increase in size is justifiable.
Just a question on that particular point. Most of that Boolean, most of the math, most of the instructions that would be necessary to do the extraction are contained in a relatively small number of methods, right? The current version, the Boolean, the bitwise operations are not spread throughout the compiler. They're centralized in accessor functions, correct?
That's correct.
So if there's a small number of those, let's be generous and say 10, right? You would have to save quite a lot of instructions in there to make up for making every option go from 1 bit to 1 byte, right? Because you're multiplying the size by 8 at least.
Yes.
So you are going to increase the footprint regardless, right? Because you're saying you're going to run fewer instructions. That's true. But in terms of the actual memory footprint of the compiler, you will have an increase because of this.
Yeah, the memory footprint is going to increase in terms of the size of the class that we have.
By how much?
So each option adds a byte to the class. So
right, but so in terms of the current options table, if you convert all of the Booleans, what is the growth in memory footprint from doing this?
It's 632 bytes in my case.
Okay, so who cares? I mean, the previous thing was 800 options it was limited to, right? So that kind of put the cap on how much extra space you're talking about. My question was going to be different. I was just curious how long it took a billion queries to, like, you made what time 2 to 3 times faster?
So it went from, I believe, 2 milliseconds to 7 milliseconds. That was a different. I may have. Okay, I might have to look at my. Hold on a second.
Okay, it's not that important. It's just it was just a curiosity how long a billion queries took.
Okay, just.
I'm not that interested. That you don't have to derail the presentation for this.
Okay.
I'll find out later.
Yeah, but
what are you writing over there?
Yeah, I'll let you know about the exact numbers, but it was 2 to 3 times faster.
That's fine.
So getting back to the issue is that given that we're only going to have just a few copies of a few instances of compiler options class, we don't really have to worry about the memory footprint, given the fact that we can perform queries faster. If it was that we were having thousands of instances of the options class, then I guess it could be a valid concern. But generally, we don't really do that many. We don't really have that many instances of this options class, so this isn't by increasing the size of the object. I don't think we are, losing out. We're paying a very big tax for that. Anyway, so in the pull request that I opened, there are a few of the fundamental components that I'm introducing. So some of them, so OMR Options.json, the options gen, and then the new format of generated option table entries, and then the option processors class, the OptionsBuilder class, compiler options class, and compiler options manager class. And we're going to talk about them in the upcoming slides.
Okay, that's a good question. Are you going, in the coming slides, are you going to be explaining the justification for using like a table-generated approach?
Yeah. Okay, so OMR Options.json is a place to contain, it's just an array of JSON objects containing like the options data that needs to get processed before it can actually be used in the compiler. So, so OMR is going to have its own options in OMR Options.json, and downstream projects can have their own version. And the script that handles that will combine the information from both for building out those tables and members and so on. So these entries get processed at compile time, so we don't have to worry about any impact on runtime performance. And a developer wanting to add a new option. Okay. So a developer adding a new option, all he would need to do is to write a new entry in that file and just rebuilding the compiler. And one of the added capabilities that we have right now is that for any kind of data type, we can have default values specified in that JSON object. Because right now, in a lot of places, at options initialization time, we have to manually set certain option flags to true because they all start off at 0. So here's an example of how an entry in the options.json file is going to look like. So it's going to have a few fields that are similar to the option table that currently exists in OMR options. So the name field is used as an identifier for this specific option. And this is one thing that we'll have to ensure that is unique. If it's not, if we do have a duplicate name, the script is designed to warn the user about the fact that you need to find a different name. And then category, like currently I'm keeping the categories at like how they are right now, but I think going forward we could come up with better category names than just M. By the way, it stands for miscellaneous, so it's not obvious, but
even better.
So description field is used for outputting information. It's just a help text information. And then the next part is option member. So this is the name of the member in the options class that that will be affected by this option being on the command line. And one thing you might notice is that I still have tr_ prefixed with these things, even though it doesn't need to be, but there is an explanation for that. We'll get back to it later. And then we can specify the data type of that member, and then the default value, and then the processing function. If we find this specific option in the command line, then that's the processing function that will handle, that will be called to change the member in the option member field. And then subsettable, currently all of them are no because I haven't added option subset handling yet.
Can you just go back for a sec? So, two questions. Why is subsettable no and not true or false? And why is default not true or false? Why is it a string false for JSON, right? Because booleans are part of the JSON spec.
Yes, I could do that too, but because the reason I did that is because in my Python script I am simply doing string comparisons, and right now what I do is directly write the default value into the output file based on okay, so I'll have to go over the options generator script to explain why this works, but I could set it to false, but then what I currently do is that I set the default value to the member initializer list, yeah, so it just simplifies having to, it could be like an integer, and then I could have 0 as a string as a default value. So
okay. And is subsettable a three-way, like yes, no, maybe, or is it just yes, no?
Yes and no, but I think I'll change that to false. Subsettable is not something I have worked on much because I still haven't fully finished the option subset handling mechanism yet. But yeah, this is just a temporary state.
Okay.
So the next part of this framework is options gen. So it is a Python script that runs at build time, and it handles the JSON files we just spoke about. And it generates multiple .inc files that are included in compiler options and CompilerOptionsManager classes. So that they include options.inc that contains all the fields that are going to be part of compiler options class, and then option initializer list .inc that that contains the member initializer list with the default values. And then option table entries lays out the hash table. Option table properties contains additional information about the option table that we use in our hashing function. And option char map is used so that we use the same. So this was an attempt to generate a perfect hash table, but then it is still useful because it allows us to perform case-insensitive string comparisons, reaching the same hash value in both Python and C++ side, so that we always have the same string matching to the same entry in the hash table. So option char map is simply an array of values that corresponds to the ASCII table, and you index into it by simply getting the char value. So these two are used for building the compiler options class, and these three are used for building the option entries table. Let's talk about the new option table that we have. So the new option table design is different from what we currently, the way we currently match command line options to the option table entries. And what we do here is we hash the table, like we hash the string and get the entry into the table, and that returns us the bucket into the hash table. And the generated hash table is simply a 2D array of option table item, and every row in it represents a bucket. And so as previously mentioned, the option table entries.inc contains the braced initializer list of the table entries. So this is how the old versus new design looks like. So previously we had to alphabetically order every single option. Let's imagine AA and AB and AD to be different options that we have. In the new design, they are not ordered, but they are put in the table according to their hash values. So every time we get into the table, we get a bucket, and sometimes it could be more than one entry because there could be collisions happening. We did try to reduce the collisions and make the hash table minimal, but given the set of names that we have, I have tried to make it as perfect as possible, trying to mimic GFER's perfect hash function generating mechanism. But the problem with that was it was taking an extremely long time. So to generate a perfect hash table, and also the table being generated was extremely sparsely populated. So that was not an ideal state, and we weren't really saving much. We weren't really gaining much by going through all that pain, which is why I decided to allow some collisions and put in a collision handling mechanism in place where every time we get a bucket, we do a string comparison with the option string and the table entries name. So in that way, we ensure that we get the correct entry.
Is this just an example here that AB and BA hash to the same value?
Yeah, it's just an example, but it doesn't have to be like that.
Okay. All right. So your hash function is better than that.
Yeah. Yeah. So what I'm using is a modified version of Bernstein's string hashing function, and I'm using a multiplier of 7, and also I limit the hash table size to twice the size of the number of entries that we have, so that we have some sort of spread and also not a very large table. Otherwise, it does get quite large.
You tried using STD map, unordered map?
I did. But the problem with that was actually my initial design before the generated thing came along.
What was the drawback?
The drawback was that it might impact startup time because we know the strings, the option names in advance. So why are we wasting a runtime by calculating a table? Because we can have thousands of entries, and it might be quite expensive to build that up.
We support constant expression, you know?
No, we don't. That would be making things simpler, but we don't, unfortunately. In fact, this was not the only C++ version specific issue I faced along the way, but yeah, it would be great if we could do that. But unfortunately, because of that, like one of the main motivations behind using a generated approach is that all of these like known strings that we have can be used ahead of time. We're not changing that at runtime, so why not just build it up and then use it? And in this way, it's much cheaper. Doesn't impact startup. Shouldn't, because I don't have the measurements, like startup measurements, because it has to be, because I would like to have it integrated within J9 before doing any kind of measurements like that. So yeah, but theoretically, it should be better this way. Okay, so this is just what I was talking about. So theoretically, retrieving an entry in this new table design should be faster than the old design on average, given the fact that we're no longer doing binary search on this and assigning, doing a less than or greater than using string comparisons. So the next class is options processors, and it's similar to how processing functions are in OMR, and it's an extensible class, and it contains different, like what OMR should do is it provide a number of standard processing functions such as set true, set false, set numeric, or something like that. And if a project wants to have some very cool and strange way of setting their own options, they can extend this class, add methods, and then specify that in the JSON object. If you might. So here is where we specify what function to use. Is that true? So that's one of the members of option processors class. For any option processing function that you mention in the JSON file, should be a member function of this class. So next part is OptionsBuilder. Nothing interesting except it's using the initialization of options and handles stuff like parsing command line and environment options, etc. And then compiler options, we've spoken quite a bit about it, and it's basically nothing but it just contains the generated file. That is generated from using our JSON object. Next is CompilerOptionsManager. So it kind of holds the whole thing together, and it's an extensible class because sub-projects should be able to determine how they want to initialize options and whether there is any new like any kind of new information that they want to add to option querying in general. So and it is also the class that you query for getting your options object specific to your compilation or just the global command line option. So once we have the option subset handling, we should be able to, any compilation should be able to query this class to return the correct options object for that compilation.
Can I ask how, oh, maybe you were just going to get to it.
Sorry?
I was going to ask how a downstream project would actually consume this. So does that project have to run its own script? And like, is there only one version of all those .inc files that's produced, or is there like an OMR version of those .inc files and a let's say a J9 version of those .inc files, and then you somehow mash them together in those different files? Or does it just produce one version of that .inc file somewhere that gets included?
So mashing of those data is actually happening in the script itself. It takes stuff from different places and just generates one version of each. So
it needs an IPath in there, presumably.
Yeah.
And it produces one amalgamated version of a .inc file. Okay.
Yeah.
So there's only one version of like the compiler options one, the previous one. There's just one version of that file.
Compiler options, yeah. It's a non-extensible file.
Is that a tape? Okay.
Yeah. And so it's a table, so that's included in Compiler Options Manager, and yeah, so So currently, in the current build system, where these files get put is under the build directory, the current build directory, and then compiler control in the same place that OMR options are located, but in the build tree, not the source tree. But that's with the CMake setup. AutoMake, that's a different story. We'll get to that later. Okay. So the next issue is that it is quite a significant change, and replacing the entire OMR options class in a single PR is I don't think it's ideal. So which is why I would like to propose a staged integration of this framework, where in my initial proposal, just introduce those basic components, and over time, I will be adding more of the option processing components along the way. And by default, these things, this new framework is going to be off. And if you want to use it just to play around with it, you'll have to explicitly turn it on. And currently in CMake build system, there are configuration options that you can turn on for that. And then for any kind of option querying, they can be, I guess, macroed away so that this dual implementation can exist. It doesn't look that pretty, so let's look at it. So what I was just trying it out and seeing what happens when you do this. So I've got two different options. So one is new options that get defined in the command line, and the new options debug. So what new options debug does is that it takes the old options and new options and compares them. And then, and in order to make any kind of option querying, you use get comp option, and then provide the pointer to compilation, and then the name of the option, and it gets processed this way. And then this is an actual usage of that somewhere in the code gen, I think. So if we want to debug any kind, if we want to get some confirmation of whether we're getting the same results from both the old and the new implementations, we can perform a compare and then get compilation options. And these would, this is not really changing anything from the current implementation unless you define those new macros, new options, and new options debug. Any thoughts about this?
Can that compare get folded into get comp option just as an initial? I mean, yes, you do things a lot, many times, but
okay.
Like, wouldn't that just automatic? You wouldn't have to change all the sites that ask for a comp option to also do the compare, right?
Just get comp option?
Yeah, just call get comp option, and then inside get comp option, it would call compare. For the new options version, it would do a compare.
The reason I did that is because when we have a more complete implementation, I would like to be able to perform some benchmarks of just querying this new class, and see the differences that we have. This way, I've got.
Yeah, it doesn't have to be left that way. I'm just saying, as an initial step, you could do that, and that would be a way of assuring when you're building with the new options that you get the right answers. You could also have it generate some initial thing that just iterates through all the options it knows about and do a compare at the beginning of a compilation, say. Right?
I see. Yeah.
That would be another way of doing it.
Okay.
Then you wouldn't have to compare on each get.
By default, it gets defined to nothing. So this is just a debug option for us.
But as startup, you can just go through all your options, pair them all, and then make sure they're all fine, and then go on to whatever you need to.
You can't do it at startup. There's the option set. Maybe,
well, whenever
maybe you can right now, but
right.
You can do it at the beginning of a compilation.
Right. When you're at the first, like, not for use.
Yeah. Okay, so after this PR, there is here's the plan so far. So going forward, there will be more added to this new mechanism. There's going to be added support for handling non-Boolean types, supporting option sets, and supporting setting options in like outside of compiler options object, and JIT config being the one that is of concern here, and adding the support for using this new option mechanism in OpenJ9, and another thing is migrating a lot of the options that we have that are specific to OpenJ9 in OMR Options.json to Options.json in OpenJ9. Yeah, and more in the future. But this is the immediate plan going forward. So this is all I had to present today, and I'd like to hear some feedback about what you think about this, and whether you have any questions regarding that.
So the options.json you have, in the future you will have one in OMR, one in OpenJ9?
Yeah.
And then the script will assemble them all together?
Yeah.
Okay.
So I'm wondering, before code is committed, is there a way to prototype the performance of any of this stuff? Because I would hate to see hundreds of hours of dev work go into building something to then have a major performance problem that would make it hard for OpenJ9 to accept the new mechanism as the way to do things. Because we're going to have, I appreciate that there's a lot of thought being put into trying to do things the right way, and it certainly seems that you're trying to be careful, but from my own experience, even when I've been careful, I've been surprised.
I agree, and this has been something that has been bothering me quite a bit. And the way I want to do it is I want to complete the Boolean option support within OMR, and then integrate that in OpenJ9, and perform some sort of benchmark by making use of the new option processing, by querying the new options class. And I think this can happen so after the initial options go in, I think we can work on adding that support in.
Right, but I guess my question is, why do we need to commit the code with no idea about the performance behavior? If you've got most of what you need for the Booleans, can't you just do a prototype of what it would look like and get the performance numbers to justify that this is the right way to go? Because I'm not an OMR committer, so I can't hold the bar for OMR stuff, but for most of the OpenJ9 stuff, there will be a question from the OpenJ9 community about the performance, and there'll have to be a discussion about it. And I'm not currently aware of a precedent of us committing code with no expectation of what the performance characteristics are going to be.
So regardless of the whatever solution we end up coming up with to change the way that options are processed, I think that if you look at all the different sites where you actually are querying an option, like you've already identified, and you wanted to change them to some kind of a macro, or something at those sites to at least being able to override whatever's happening there, depending on how you're building, I don't think that is a waste, because I think that, like I said, regardless of the option approach, we may want to do something like that in the future. So you can, I think, go throughout the code base, certainly through OMR, and add some kind of, I don't know if it necessarily has to be a macro, but add something in all those places to make it easy for you to override. And then I think that makes it easier for you to actually do that kind of prototype and benchmarking that Andrew's asking about before you go too far with it. Because I think that, you've done most of the work already to actually implement, to actually get this into a table, right? So you just need to be able to test it out. And the only way that you're really going to be able to prototype that is in something real, I think. And for you to get to that stage, I think that doing the work to change all those sites to something that you can override.
Yeah.
Isn't everything mostly doing comp get option, providing that name, that same name anyway?
Yeah.
So do you really need to change that generic call or to some other kind of generic call that can be modified? Like that's already a query off of compilation. Right?
Yeah, I was going to say I'm not a fan of having a macro sprayed throughout the code. It makes it harder for a lot of IDE tools to know the right thing to do. I mean, there is the comp get option. Can't we just hide all of that macro, whatever's going to happen in there, inside there, and not have to spray the whole code base and like collide with changes from all kinds of people that are trying to get stuff into the compiler?
Sure, that might be possible to do. What else other than comp get option? How else is this queried?
Comp get option. So that is queried for Boolean option types. That's how it is done. But for other option types, it's usually like an accessor method that returns the value.
Okay, so it should be pretty easy then for a Boolean option then.
Yeah, which is why like Boolean option is what I dealt with first. Because,
right, but why touch the whole code base for the Boolean option when there is already a single API? You can just change the implementation of that API, and then you don't have to touch the code base. I agree that some of the accessors may be more complicated, and maybe some of those need to be touched. That'll have to be discussed, but like I don't see why we need to touch the whole code base to turn what was seemingly a nice, simple comp get option into a macro that's opaque.
You could move whatever was defined for that macro into the compiler.
Yeah, I think we could adapt that get option method to handle the two kinds of option query mechanisms. Yeah, so anyway, so that we don't really have to use the macros that the way I did it. There was just one way of doing it where I found a way to enable both comparisons and lookup of the old versus new, but obviously that's not the cleanest one, and it's also a lot of work trying to change all the places that the options get queried from. It is much easier to actually change the function.
Off the top of my head, one reason, just putting this out there for the sake of completeness and everyone's information, one reason the macro would work better than using the current API is we're changing this from passing in a field or an int to grabbing a field from a struct. So we can't just, we could try using, say, pointers to members to make this work, but there might be some subtleties in how we have to make that work if we want to preserve the current API.
I'm just saying that I'm not a fan of spraying a macro through the code base because I've worked in code bases that are based on macros and they're awful because IDEs don't handle them well. Not that we have great IDE support at the moment, but I don't see why we should make it harder. Minimizing the number of areas you need to touch, especially until you know that this is got the performance characteristics and things that will allow it to be approved by the community, would seem to be the most prudent thing, right? I'd hate for you to go and spend hours trying to get all of the options stuff converted and deal with all the merge conflicts and cleaning up all the broken builds and other things that will happen to then have to go and say, oh, well, that actually didn't work. And now, I'm not sure that there's a benefit there. Just seems like a lot of busy work because there's no real need to change the API. Like it's a Boolean query. Is this option set?
So are you saying that for some time you might have to have two API calls to deal with the get options because now you're passing in a different type?
Well, the problem is the name that you're giving has to turn into a field identifier in the options object, right? Yeah. That's not. There's no way to pass that as a parameter in
can provide member pointers.
Pointers to members, which are ugly and have their subtleties. So that we might be able to make that work, but
but that won't give you the answer that you're looking for, right? That won't tell you if the performance of the thing that you're actually trying to change it is going to be comparable to, and ideally better than what's already there.
Yeah.
So,
well, yes, you're right, because the underlying mechanism for actually fetching that field would be very different.
Yeah.
I have a feeling you might have to just go through and change it for the prototype, like prototype it for OpenJ9 and just hack it to the thing that you think it's going to look like, and then using a macro or whatever. Right?
I want to say you might be able to write a set script that will automate a lot of that transformation.
Yeah, that's one way.
They're always arrow, get option, parentheses, and then the option.
Yeah.
Yeah, but to your point, Andrew, yes, Nazim will be careful with it, and we are not going to be committing anything until we are sure of the performance implications of it.
Okay, cool.
I guess we also still have to figure out what performance test would you run to. That's kind of compilation time that you're worried about, right? So I guess a startup test that's not using AOT or something like that. Right?
Well, there would be the startup test, but you can also measure compilation time on any of the OpenJ9 benchmarks, right? If you just turn the verbose log on and get the total compilation time, and you can compare that, and that will cover like the entirety of all of the compilations, so that you know the effect, right? The startup time may not be the most telling. The actual compilation time will be the thing that really tells you how much you've affected it.
Another thing that I don't think you mentioned that we could do with this as well is that we could actually write some tests for it. Some relatively straightforward unit tests. They're not going to be, exhaustive tests, but it's better. It's certainly miles ahead of where we are right now with how the options are actually validated. So I think that there are opportunities for adding some unit testing for this as well.
A couple things I'll add. We did have a discussion on this in August of 2018. I think we have a recording too, where we initially, I think you opened the issue for 2835. There was a couple of things noted by several people, which I think we should take into account. Off the top of my head, I can see aliases to options. For example, if an option gets deprecated or renamed, downstream projects need to keep the alias alive because it could be documented externally. Talking as an OMR, or I guess OpenJ9 committer, we have publicly exposed and documented options, and if the name were to change, that would be a big problem for us. So we should consider adding alias support into the option name. And a couple other things is printing help and documentation. I'm not sure if we've decided whether that's an OMR thing, but I noticed you have a description there.
Yeah.
And I'm not sure if it's...
So help text is going to be part of that mechanism. So you could specify the option, like xshape-help, and then the option name, and that will print out that message. And doing -help would actually dump all the options in their description.
Okay, cool. And I think there was another issue regarding how do you enable and disable a feature. So today we have to create two options, one for enabling and one for disabling, and whether something like that will be built into the new option processing. So if I have feature X, can I specify enable feature X and disable feature X on the options?
Feature X will be true or false, ideally. Eventually we'll get there, but right now I'm still using enable and disable at the same time because of the fact that we're in the transition phase. But eventually it would be just a boolean field determining that option, like feature X enabled, yes, true or false. So that's the only place we'll need to look at.
But on the command line, though, it would be being able to say disable blah 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 or enable blah 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 is certainly certainly something that makes more sense, right? Like, what are you proposing on the command line for that? Because
so if you specify enable feature X on the command line, then the option processing is going to set that to true. If you do disable, it's going to keep it at false, and if it is true, it will set it to false.
So there's an enable and disable prefixing on the option name, or how's that working?
So you'll have an entry in the option table that gets matched to that command line string.
Right, but so take an optimization, right? We generally have an option per optimization that says we want to be able to turn this optimization on and off, right?
Yeah.
At the moment, 99% of them are on by default, which means that there's no enable option in the current table. There's a disable, right? And there are ones that are in development where somebody has not enabled them by default. And so there is no disable, but there's an enable in the table, and it's all kind of asymmetric and yucky, right? And when somebody goes to change an optimization from being default disabled to default enabled, not only do they toggle the state of the flag, but they also go and change the option table to change the enable to a disable. Right? So what are you saying? How are you saying that the per optimization option is going to work? For example.
So I think that the original idea that was proposed many months ago, or the concern that was raised, was that you're really just describing, like in your table, you're really just describing the feature that you're interested in. You're not actually saying enable or disable it. You're saying this is a boolean feature. It can be on or off.
Yeah.
And your processing framework would be able to recognize that if somebody's on the command line says enable that feature or disable that feature, it'll toggle that boolean accordingly.
Yeah.
So you don't actually have to go and add two different options on the command line for enable and disable. It'll be able to recognize that just based on the fact that this is a boolean feature.
Yeah.
You'll handle that just for free.
Yeah.
So I think there's a way of doing that, or making that part of this framework.
Yeah.
Presumably, that's one of the advantages of having a table gen approach, right? Is that you can change the logic for how it interprets the name of the option and what it actually generates into the code, right?
Yeah.
Whether it's enable, disable, or plus minus, or whatever. Just an example. I'm not saying you do that. Set reset. Set clear. Lots of options.
And you can alias them all together too. You can have.
Stop that.
Any other questions for Nazim on this?
Do you foresee any challenges with other types of options, like non-Boolean options? Do you think there's going to be any?
I don't think there should be issues with the option data types, but what I am a little worried about would be handling of the JIT config. So we'll have to look into that. I've tried moving away from using offset-off operations for option processing, so I'll have to see what I can do about that. Eventually, we might have to end up doing offset-off. I don't know. So.
It's going to be. I'm not sure that JIT config in OMR is actually shared with the JIT config in J9.
They're not shared.
Class.
It's just
or struct or something.
Yeah.
So that's even more weird.
Yeah.
Same with AFE.
The last question I had is, how stable is the layout of the the layout that's generated by the table gen tool, right? Like if no options are added and you run the tool multiple times, all the same options will end up in all the same places in the hash tables and everything.
Yes, it should.
Should or do?
It should be deterministic, shouldn't it?
Yeah.
You're it's the same.
So yeah, they will only be changed if you add new options to the JSON object. Otherwise, it should always result in the same layout.
I only ask for postmortem core file analysis because I know the service guys will be keen to make sure that they can figure out where the hell the options are.
Yeah, no, they will be generated the same thing. It used to be different. It was not the case when I was trying to intelligently determine the the associated values with the characters when I was trying to make a perfect hash table, and that was resulting in a different table each time. But now it has been the same, and it should be the same. I don't see any reason why we wouldn't.
Really, it's not the hash table you care about, though, right? It's the layout of the fields in the options object, I think, that would be of more interest being deterministic, right? Because that's the thing you're likely to have a pointer to an options object.
Yeah.
No way of decoding what that options object is, so I need to figure out which Boolean field it is that I care about.
Yeah. So, yeah, they will be the same all the time.
It would be worth at least having the mental thought of if all you had is a core image of the compiler while it was running, how would you figure out which options are on and off, right? From the memory image, right? Right. So say an optimization crashes, right? And we want to go and see, okay, well, was this thing enabled or disabled because it's optional? Right? Somebody might have turned it on or not. So then we want to go and ask, what's the state of that option? How would we do it? Using GDB or whatever.
It does raise an interesting question, though. Does KCA know about options objects at all?
It does not.
It does not. Okay.
You can load the core file in GDB and execute the get option. No problem.
Yeah.
But I think that should be a requirement. We should write a test that the generated header or whatever is always the same.
Okay.
Options get included everywhere, and Tcache would just not work if you were to change from every name.
Yeah.
Okay. Anything else? Okay. All right. Thank you very much, Nazim. Looks like it's some good progress. That's all we had for this week. We'll have another call in 2 weeks. Thanks, everyone. Bye.
Thanks.